Look up at the night sky and you see a picture of absolute stillness. The stars and Milky Way hang there, unchanging, just as they have for all human history. In April 2026, astronomers observed the supermassive black hole in galaxy J1007+3540 suddenly wake up. After 100 million years of silence, it erupted, firing jets of superheated plasma into space at near light speeds. 500 million light-years away, another event is unfolding. Two supermassive black holes, each weighing up to 1 billion times the mass of the Sun, are spiraling toward each other. They are expected to merge within the next century. Our own central black hole, Sagittarius A star, is currently quiet, but its surrounding environment preserves the evidence of past eruptions, showing that this inactivity is only a temporary state. The silence of the night sky is a mask for a reality governed by violent, unpredictable collisions and massive outbursts of energy. This first direct radio image of a supermassive black hole reveals a glowing ring of superheated plasma. The dark void inside is the event horizon, the boundary where gravity is so strong, not even light escapes. These objects exist at vastly different scales. Stellar mass black holes, born from individual collapsing stars, are relatively small, but the supermassive giants anchoring the center of galaxies grow to weigh millions or billions of times more than our Sun. At the top of this scale are anomalies like Phoenix A. It is an ultra-massive black hole with a mass estimated at 100 billion suns. At these extremes of mass and volume, gravity creates environments that challenge our current understanding of physical laws. Some black holes reach these sizes through hierarchical merging. This is a process where black holes in dense star clusters collide and combine over and over again. These smash-ups create black holes in the mass gap. Normally, massive dying stars explode entirely, leaving nothing, but merging circumvents this. In 2025, researchers saw two forbidden-range black holes collide, forming a single object 225 times our Sun's mass. Violent collisions can physically eject the resulting black hole from its galaxy. Astronomers recently confirmed a rogue supermassive black hole traveling through intergalactic space. This 10 million solar mass rogue is moving at 2.2 million miles per hour. It drags a 200,000 light-year-long tail of gas behind it, which is actively collapsing to form new stars. These are not stationary drains at the center of space. They are mobile engines capable of reshaping entire galaxies as they move. The James Webb Space Telescope is currently looking back to a period just 500 million years after the Big Bang. Inside a faint object known as a little red dot, it identified a black hole named Capers LRD-Z9. It is already 300 million times the mass of our Sun. In a modern galaxy, the central black hole is usually just 0.1% of the total stellar mass, but Capers LRD-Z9 accounts for up to 50% of its host galaxy's mass. Finding an object this massive so early in time suggests that our models for how black holes and galaxies co-evolve may require a significant reassessment. In 1974, Stephen Hawking provided the mathematical proof that black holes are not perfectly black. He theorized that quantum fluctuations at the event horizon create pairs of particles. If one falls in while the other escapes, the black hole slowly leaks energy and begins to evaporate. This leads to the information paradox. If a black hole evaporates completely, everything that fell into it appears to be permanently gone. The permanent destruction of information violates the law of unitarity in quantum mechanics. This contradiction has been the central unsolved problem in theoretical physics for 50 years. If a black hole can erase the building blocks of matter, it means our most fundamental descriptions of reality are incomplete. This mystery sits 26,000 light-years away from Earth. Sagittarius A star is the 4 million solar mass black hole at the center of the Milky Way. Its existence was confirmed by astronomers like Andrea Ghez, who tracked the motions of stars orbiting an invisible, massive point at the galactic center. Sagittarius A star is currently in a quiet state, but its history is one of very violent episodic feeding. The evidence for its last eruption sits right above us. These are the Fermi bubbles. massive structures of gamma-ray emission stretching 25,000 light-years above and below the galactic plane. In cosmic terms, that eruption happened recently. We currently have no way to predict when the center of our galaxy will wake up and become active once again. These dormant, impossible, physics-breaking objects are the most extreme entities in the universe, and we are only beginning to understand them.